In this video, we're going to talk about acceleration. So we saw in the last video that velocity was equal to change in distance or displacement over change in time. So velocity describes how quickly we are covering ground. Now acceleration describes change in velocity over change in time. So let's write that down. So change in velocity over change in time. So what does that really mean? If I'm, say, going from 20 miles per hour to 30 miles per hour, you would say I'm speeding up. I'm, picking up speed. But also, I'm accelerating. So acceleration gives us a way to describe how velocity is changing over time. At this point, you should notice that velocity is really the slope of the position function. Notice that this is the formula for slope, and that equals the slope of the position function, or the slope of the displacement function. So slope of position. Okay, and acceleration is the slope of the velocity function. So again, we're looking at change in velocity over change in time. Delta y over delta x is a formula for slope, so this is really just no different. It's just specifically for velocity. So the units for acceleration, unlike velocity, are a little less intuitive than they were in the last video. So let's look at an example to see if we can figure out what the units for acceleration are. Okay, so let's say that I am traveling at 20 meters per second, and over the course of 10 seconds, I pick up speed and I end up traveling at 30 meters per second. Okay, so remember that acceleration is change in velocity, so delta v, divided by change in time, so delta t. And I should also mention here, when we talk about delta v, we're really talking about final velocity minus initial velocity, divided by final time minus initial time. Okay. So, plugging into this formula, I see that my final velocity is 30 meters per second, and my initial velocity is 20 meters per second. Okay, and then I see that my change in time is 10 seconds. Okay, so now I can simplify that down to 10 meters per second over 10 seconds, or 1 meter per second over 1 second. Okay, that looks a little different. We have some units over another unit, meters per second over seconds. Okay, so doing a little bit of math, we see, okay, I have meters per second divided by seconds. Okay, you know that you can rewrite division as multiplication if you flip the second. So I have meters per second times 1 over second. So then that simplifies down to meters per second squared. Okay, so my units in this problem are 1 meter per second squared. So those are the general units for velocity. You might see kilometers per second squared or miles per hour squared, but it's always, some unit that describes length and then some unit of time that's squared. At this point, we should also mention that, like velocity, acceleration is also a vector. Acceleration is dependent on direction and magnitude, just like velocity. Because acceleration is describing velocity, which is a vector, acceleration is also a vector by default. Now let's look at a slightly more interesting example. So, let's say that I have a car moving in a straight line. It's traveling at 4 meters per second. Actually, let's call this car 1. So car 1 has an initial velocity of 4 meters per second. And then it picks up speed and it ends up at traveling at 10 meters per second. And it takes 2 seconds for this to happen. So I'm going to write that as delta t equals 2 seconds. Now let's say I have another car, let's call it car 2. And let's say, again, traveling in a straight line, it goes from an initial velocity of 20 meters per second and picks up speed and ends up at a final velocity of 30 meters per second. And let's say that it takes 10 seconds for this to happen. Okay, so 2 questions. First one, which car is moving faster at the end of their respective time intervals? And then which one has the larger acceleration? Okay, so it's pretty obvious which one is moving faster. Car 2 is traveling at 30 meters per second, while car 1 is only traveling at 10. So car 2 is definitely moving faster than car 1. It's covering more distance in a shorter amount of time. Now, which one is accelerating more? So let's figure out acceleration for car 1. Okay, so car 1. Remember that acceleration is change in velocity over change in time. It's always going to be final velocity minus initial velocity. Change in time in this case was 2 seconds. Okay, so with a little bit of math, we see we have 6 meters per second on the top divided by 2 seconds, so that's 3 meters per second squared. Okay, now let's look at the acceleration for car number 2. So the acceleration for car number 2 is, again, final velocity, so 30 meters per second, minus initial velocity, which is 20 meters per second, over change in time, which is 10 seconds. Okay, again, doing a little bit of math, 30 minus 20 is 10, and then 10 over 10 is 1, so its acceleration is 1 meter per second squared. Okay, so which car is speeding up more, or has larger acceleration? Well, we see that car 1's acceleration is 3 meters per second squared, and car 2 is 1 meter per second squared. So, car 1 has a larger acceleration than car 2, even though car 2 has a larger velocity. So, in closing, we see that acceleration is the rate of change of velocity. It tells us how quickly velocity is changing. Acceleration can be a little bit difficult to grasp because it is a rate of a rate. So let's look at acceleration again. Acceleration is change in velocity over change in time. So it tells us at what rate is our velocity changing. Okay, but remember that velocity is change in distance which is really just displacement. We're talking about linear motion over change in time. So velocity tells us how fast are we covering a certain amount of ground, while acceleration tells us how fast is our velocity changing. How quickly are we picking up speed, or are we losing speed? Like if we're slowing down, you're decelerating. If you're speeding up, you're accelerating. So acceleration gives us a way to describe changes in velocity. Okay, so if you are moving at a constant rate, you're moving in a straight line, so you're not changing direction, and you're maintaining a certain speed, let's say 20 miles per hour, and you stay at that speed, then acceleration isn't changing, and your acceleration is 0. But if you're speeding up, so you're going from 20 miles per hour to 30 miles per hour, then you're accelerating, you're speeding up. Acceleration describes that change in velocity. Okay? So it can take a little bit of time to grasp the difference between acceleration and velocity. Acceleration is a little bit tricky because it is a rate of a rate. Just give it some time. It's an important concept to grasp, and will come up a lot in our next video when we cover free falls.